Today's video will explain how to design a large inheritance tree. Hello, I'm James Helfrich. It can be challenging to design a large inheritance tree so that it's adaptable. In other words, we can accommodate changing and new requirements by the client without fundamentally changing our overall design. This video will demonstrate one such technique using user interface elements otherwise known as widgets as an example. Okay, let's get into a few best practices. Okay, let's get into some best practices. First of all, every aspect of a design should map to a design concern, be that a function or a class or really anything. Remember, the whole point of software is to model something in the real world, and if something in our design does not reflect that model, we have a problem. And this is not optimal because oftentimes requirements change. We need to add new functionality or adjust existing functionality. When our design is out of alignment with the problem domain, these changes tend to be more expensive than necessary. The next best practice, do not worry about balancing the inheritance tree. There is little benefit to a balanced inheritance tree. There is no performance win and definitely no maintainability win, especially when those new elements you add to the inheritance tree don't map to the problem domain. It is better to not devote any effort to a constraint which does not improve the design. Next, each level in the inheritance hierarchy should mean something. Not only should each class mean something, but each level should as well. It is best to clearly identify these levels early in the design process. Next, unambiguously communicate the meaning of each division in an inheritance tree. And this is related to our previous best practice. We should communicate our design strategy with other members of the development team, and this can be done in the code base with comments or through other team communication mediums. Finally, choose base class names carefully. A vague or generic class name is a good indication that is not mapped to a design concern. We call these things code smells. It's like when you open the refrigerator, something doesn't quite smell right. Is that because you have tuna fish, or is that because something's bad? Most of the time it's because there's something bad, but sometimes it's tuna fish. Now, bad base class names are the same thing. Almost always it's an indicator we have a poorly designed inheritance tree. Sometimes that's not the case. That's why it's a smell and not a hard and fast rule, but most of the time it's the case. Whenever you have difficulty naming something, whether that's a class name or whether it's a function name or even a variable name, reflect on whether that programming construct is really needed. Okay, let's take a look at an example here. I want to create a master plan for an inheritance tree representing the following problem. So I'm going to have a graphic user interface consisting of several types of widgets, and a widget could be a button, a scroll bar, an edit controller, whatever. Each of which is made of several different parts. The complete set of widgets and parts is not known at the beginning of the project, and this is almost always the case. The client doesn't fully understand the problem domain, and neither do we, and that's why the code writing process is a discovery process for all involved, not just the mechanics of turning the problem domain into code. Okay, so let's devise a plan here. First of all, we're going to have our base class, and every widget shares the same base class. The next level down is we're going to have a compound widget, and these are widgets which are made from many primitive elements. Now below that, we're going to have a simple widget, and this is a self-contained component that the user can interact with. And finally, below that, we're going to have a part, and this is one object which may be drawn or accept input. Okay, so this is kind of my base idea here. I'm going to have these 4 different levels, and we're going to see if we can fit things into this. Now we're going to start with our base class, which is widget, of course. We're going to have one. Everything is going to be a type of widget. And then we're going to have a scroll bar. And this is a compound widget because remember, we have the track, we have the up arrow, we have the down arrow, we have the slider itself. But we have other kinds of compound widgets too, like edit controls and spin widgets and things like that. And all these are related through inheritance to the widget because all these are different types of widget. Okay, so let's dive in a little bit deeper here. We're going to take a look at the scroll bar, and it's going to have a button. We're going to have the scroll bar is going to have a thumb, and it's going to have a track. Now notice the next level down is not inheritance. In this case, it is composition. The scroll bar has 2 buttons. It has a thumb. It has a single track. Okay, let's dive down one step further to the part, and the button is going to have a label, and it's also going to have a rectangle. And now we can see how our master plan is going to fit into how we're going to create the actual widgets. This is example 3.9.1 in the large inheritance tree chapter of the software design textbook.